Next up, we are bringing Jim Anthony in. There you go. Hello, Jim.
Hi, ladies. How are you?
Good. So with you, I know there was a slight change in the agenda today, so we're just going to hand over to you to run with this. Thanks.
Yeah, thanks for the quick intro. And I will try to do my best to keep you only as far behind as you are on your schedule. I won't put you any further behind. Very quickly, let me present something. I'm going to share my screen. Yeah, don't show me that again. Thank you very much. Oh, wait a minute. Entire screen. There we go. Sorry about the technical difficulty. Let me pop a slide here. Quick screen check. Can someone confirm that they can actually see that? For those of you who don't know who AppGate is, we are a zero trust network access provider. Think of our solution. It's called AppGate SDP. Think of it as a network overlay. What we do is we make sure that the things on the left side of this screen are properly authenticated and authorized to access things on the right side of the screen. And that's just it in a very quick nutshell. The way that we do this is through a concept of an agent running on the left side on these devices, user devices, IoT devices in the network, things like that, talking to a gateway, providing protected access to things on the right. And we do that through something that is very unique to us, through something that we call a direct routed architecture. So there are a lot of competitors in the zero trust network access space, but nearly 100% of them that are not called AppGate use something called a cloud routed architecture, which requires your network traffic to go to their cloud where it's analyzed and authorized to go deeper into the network to these private resources. We don't do that. So we've implemented a lot of other things that make this solution not cloud routed, which means you can use it in your own private networks. You can use it without any access to the internet. And there's other things like that that come into play. But you'll notice Kubernetes is absolutely one of those things that we can provide protected access to on the right. On the network, Kubernetes is really nothing more than a DNS name or IP address, a port, and a protocol. That's how you define what it is that you need access to. But the unique and interesting thing that I'm here to talk about today is thinking of Kubernetes as a source. Think of Kubernetes as a client needing access to some protected data. Whether it's Kubernetes or some EC2 instance or some RDS instance, it doesn't matter. If it's definable on the right-hand side of the screen, we can control how a Kubernetes namespace can gain access to that particular thing. So let's take a look at it in action. Apologies for the video weirdness. I do have a Kubernetes cluster deployed in Amazon. Here's some of the commands that I use to get this installed. So there is a 2-node cluster running up in Amazon. I use Helm to install the AppGate sidecar injector. Basically put it in its own namespace. And then I can execute a command here. Let's do that. Basically showing that I do have a couple of, pods running with this Kubernetes injector. From there, I can deploy another namespace and tell it to use the SDP injector for that namespace. What does this all mean? Well, ultimately what it means is that I'm driving traffic from one namespace through the AppGate sidecar, using that sidecar to control what that particular namespace has access to. So as an example, if I connect to that namespace that's being forced to use the injector, you can see that I'm going to just get a shell on the thing. And if I ping a local resource, in fact, I think it's in my cache here. Let's just ping 10.201.4.58. So that happens to be the same subnet as the subnet where my Kubernetes cluster is deployed. And so you can see I can successfully ping it. I have access to it. Well, so you're probably thinking to yourself, well, what's the big deal about that? That's not really all that important. That's not really all that critical. But let me show you what makes that happen. From an AppGate dashboard perspective, I can dig into the AppGate console for my environment, and I can find that EKS user that's logged into the environment. And the first thing that I can notice is I see that he's actually connected to 6 different data centers. So this exposes one of the concepts of AppGate that we actually have something called multi-tunneling enabled in all of our AppGate clients. And so that includes the Kubernetes sidecar injector. So within that injector, I have pathways to all these different data centers spread all over the world in my use case, because that sidecar, that Kubernetes cluster needs access to them for one reason or another. Let's pick on one particular connection. So within my AWS Virginia data center, I was given an entitlement called QA servers via K8s. What this says is that I actually have a TCP rule that allows me to reach port 80 on 10.201.4.58. I also have an ICMP rule that allows me to reach that same IP address. And thus, my ping is allowed to talk to 10.201.4.58. But if I dig just a tiny bit deeper and look at the details of this entitlement, let's go and look for this entitlement. I have a lot of entitlements in my world. Here's that particular entitlement. Let's look at what granted me access to it. So instead of listing a 10.201.4.58, I'm actually using an industry unique standard of AppGate that basically says, I'm not going to give you a DNS name. I'm not going to give you an IP address. Instead, I'm going to give you an AWS query looking for a tag with a name of K8s and a value of dev. Anything in that AWS environment that has that tag name with that value is going to be granted TCP access to port 80. Similarly, anything with that same tag name, same tag value, being granted ICMP access as well. So within my AWS world, if I look at my EC2 instances, there's my K8s tag, and I do have something with a K8s tag name and a value of dev, and its IP address is 10.201.4.58. That's what gives me the ability to reach that destination. The beauty here is that this is dynamic. The AppGate gateway that's actually controlling my access is constantly querying that AWS environment. If that tag changes and it's no longer a dev tag, it's tagged something else, I'm specifically granted access only if it's tagged dev. So once that tag changes, after a few seconds, that gateway will reissue the query, get a new result set back, and figure out that this end user or this K8 cluster has no access to that destination. So you see my pings have stopped scrolling. In fact, if I hit a couple of blank spaces there, you see my ping is no longer working to that particular destination. I can come back in and change the tag back to dev. And again, within a few seconds, you'll see that ping starting to roll again. The beauty here is that the rules can be made very static using these queries, but the result sets that come back from the queries are very dynamic. I can shift what a Kubernetes cluster has access to based on metadata, as I've shown you here in AWS, but I can do the same thing on a VMware cluster. I can do the same thing in Azure, GCP. I can even use Illumio lookups to decide what a Kubernetes cluster has access to. So that's one quick little demo. You might want to do that, considering you've got a multi-project cluster out there that you want to make sure that particular namespaces have access to one data repository that's outside of the cluster versus a different data repository that's outside of the cluster. Maybe you've got a green database versus a red database versus a blue database that are all associated with your various dev teams. And so you can do that using this metadata concept that I just showed you. Now, let me give you one more scenario. I'm going to break out of this ping command. I also have the ability to, since I'm manipulating traffic, right? I also have the ability to black hole traffic. So I could actually come in and issue an entitlement to that Kubernetes sidecar injector that says, if I look at my default gateway site, I can actually block internet traffic. So imagine a scenario where you've got a development team that's trying to do some work on a Kubernetes environment. You don't want them to download packages off the public internet for whatever reason. Instead, you want them to download those packages off of an internal resource that's already been pulled off the internet, pulled off of its appropriate repo, tested for bugs, for anomalies, for code infringements, whatever you're looking for, but you have a safe and secure repository that you want them to draw from. So I can actually block their ability to reach the public internet whether it's all hosts, right? Anything on the public internet, or it's very specifically a GitHub or some other repository that you don't want them accessing without going through your code check process. And so what does that look like? Well, because I'm blocking UDP, I'm also blocking DNS lookups, right? So keep that in mind. So what I have to do then is I'm going to flip back over to my my terminal windows here, and I'm just going to ping CNN.com as an example. So this is here on my local machine, pinging CNN.com. And the only reason I did that is I wanted to get the IP address for CNN. So if I grab that IP address and come back over to my shell on my Kubernetes cluster and try pinging that same IP address, what happens? Well, obviously CNN.com is something that you should be able to have access to under most circumstances, as it's a public facing website. But the fact of the matter is that because I've black holed that traffic, the Kubernetes cluster does not have access to it. In fact, if I try to ping CNN.com, you'll see the same result, because it's actually going to issue a DNS request that's also being black holed. So you don't get any name resolution or anything for it. So again, absolutely controlling not only what's allowed, but also controlling what's not allowed at the network layer within the AppGate or within the Kubernetes cluster by leveraging AppGate SDP to do that. That was it. So I will stop sharing and flip over and check out and see if there's any questions that have popped up.
Jim, thank you so much. That was great. There is one question for you. We're going to actually leave you to answer that in the chat if you're okay to do that. Appreciate you being here today, and thank you.
Thanks,
so
Jim.
it looks like the question that popped in was, is there a tool supported way to manage such security model? Tags look like a manual way of managing it. Absolutely. So I showed you an example using tags, but the whole AppGate environment is 100% API enabled as well. So you can let your imagination run wild, leveraging APIs to manipulate what's allowed versus what's disallowed. When those changes are made, I can even force changes to be pushed to the various clients. There's lots of different ways that you can do that. Another question just popped in around multi-account models. AppGate doesn't take into account multiple accounts. In other words, multiple accounts are irrelevant to AppGate. It's not that it breaks AppGate, it's that they're irrelevant to AppGate. AppGate operates at layer 3 and 4 in the network stack, and that's it. It doesn't care that an IP address for destination A is in account number 1 for Amazon and destination B is in account number 2 for Amazon. Doesn't matter. So as long as it can reach the IP address at the network level, you're going to be good to go with that.
Awesome.
So that's it. Thank you for the quick one.
Thank you, Jim.